Hi everyone, thanks for joining me. I'm Don Perugini from Presagen. Today I'll be talking about how our obsession with AI accuracy supremacy is a race to the bottom for robust and reliable AI in healthcare. Achieving new accuracy records in healthcare can be groundbreaking. It can also involve solving a new problem or producing an innovative new algorithm to better solve an existing problem. These scientific achievements are typically newsworthy and should be celebrated. However, when you're talking about using AI for healthcare in the real world, in clinical practice and on patients, the AI needs to be consistently accurate, or what we call generalizable. The AI needs to be robust and reliable to work across all scenarios that it's intended to be used for. It needs to be unbiased and scalable to work reliably for all patients, regardless of who they are or where they live. The question is, does our obsession with accuracy help AI transition from the lab into the real world? Do AI competitions like Kaggle and beating AI accuracies in benchmarks necessarily translate to better AI tools in the real world? The problem is AI accuracy can be misleading for two reasons. First, accuracy is only as good as the data used to test it. If you're testing the AI on one or a few clinics, it's easy to overfit the AI to be highly accurate for that type of clinic or patients that attend that clinic. This may not be representative of the accuracy for the other clinics and patients in the real world, which may use the AI, and thus can lead to bias. To solve this, the data used to test AI algorithms need to be diverse, or better still, globally diverse, to ensure that the AI is globally applicable. Secondly, accuracy provides little insight into how reliable and robust the AI will likely be in practice. So, what does this mean, and how do we solve it? Well, that's the focus of this webinar, so let's do a deep dive. Let's use a simple example of training an AI algorithm to identify pictures of hot dogs. This example could have been detecting cancer in images, but for simplicity, let's use hot dogs. To create AI for real-world use, there are several steps. First, you collect the data to train the AI, which in this case are images with and without hot dogs. The AI trains using this data, which in essence looks for patterns or features in the image to identify hot dogs and distinguish it from, say, burgers. The AI training will produce multiple AI algorithms. So why multiple AI algorithms? Well, it's just like in class at school. Teachers teach different students the same material. However, each student learns differently and some learn better than others. With multiple AI options available, we need to assess and test each AI to determine which one will likely perform best in the real world. And finally, the best AI is selected and can then be productionized or operationalized to be used in the real world. So the key step in AI, the creation process, is how do we assess and test AI and determine whether it is likely to be reliable and robust enough for real-world use. To explain this, we will now talk about how the AI output and how to interpret it. When the AI analyzes a new image to identify if a hot dog is present, it outputs a number or a score from 0 to 1. This number is used to tell us whether the AI sees a hot dog in the image and its confidence in seeing a hot dog. A number of 1 means that the AI is very confident or certain that the image contains a hot dog. A number of 0 means that the AI is very confident that the image does not contain a hot dog. A number of 0.5, so halfway, tells us that the AI is unsure whether the image contains a hot dog. Therefore, we say that a score above 0.5 means the AI sees a hot dog in the image, and a score of less than 0.5 means that AI does not see a hot dog in the images. And the closer the score is to 1 or 0 indicates the confidence that the AI sees a hot dog or not, respectively. Okay, so in this example, there are 4 images and 4 scores output by the AI. The first 2 are clearly hot dogs, and the AI outputs 0.9 for one and 0.6 for the other. A value above 0.5 means that AI sees a hot dog, so the AI is correct for both of these images. Similarly, for the bottom 2 images of burgers, the AI score is less than 0.5. So the AI score is less than 0.5, so the AI does not see a hot dog in the image, which is also correct. It is also important to note, although the AI got all of the images correct, it is more confident in its assessment of some of the images than others. So with the top image, it is very confident that the hot dog is confident that it is a hot dog with a score of 0.9 out of 1. But the second image, it is less confident with a score of 0.6, but it's still correct. Likewise, with the last 2 images of the burgers, the AI is more confident with the top burger image with a score of 0.1 compared with the second burger image with a score of 0.4. This metric associated with AI confidence is key to assessing whether an AI is likely to be reliable and robust in practice. Our view is that selecting AI, which is both confident and accurate during testing, will likely lead to AI that is more reliable and robust in the real world, compared with selecting AI based purely on accuracy alone. I'll explain why. Let's consider an example of comparing 2 different AI algorithms, algorithm 1 and 2, by testing them on 4 images. As can be seen on the slide, algorithm 1 gets all images correct with 100% accuracy because it was able to identify images with and without hot dogs in all 4 cases. Algorithm 2, on the other hand, gets one wrong, the second image, and only achieves 75% accuracy. Just looking at accuracy, algorithm 1 looks better than algorithm 2. However, if you look at the confidence of these assessments, algorithm 1 was less confident, close to unsure in its assessment of whether a hot dog was present or not for all images. Algorithm 2, on the other hand, was very confident in its correct assessments and less confident with the one that it got wrong. What does that mean? It means that the lower confidence with algorithm 1, or it being less sure of the assessment, is almost like guessing. The high accuracy was probably more like the luck of the draw. It just happened to guess right for all the images rather than smart enough to really be able to identify hot dogs in the images. Therefore, algorithm 1 is likely to be brittle, and the 100% accuracy is not likely to be a reliable measure of its performance in the real world. Now, with algorithm 2, it was very confident in its correct assessments, unsure when it got the image wrong, which is okay because AI is telling us that it's less sure. Therefore, algorithm 2 is more likely to be robust, and the 75% accuracy is likely to be more reliable when used in the real world. In other words, to have AI generalize well in the real world, you want to choose AI that has good confidence in its predictions when testing, even at the expense of accuracy, because that AI would generally do better in accuracy overall on new unseen data in the real world when it's used in practice. To conclude, accuracy and confidence in AI creation are key to more reliable and robust AI for use in the real world. Focusing on accuracy alone can be misleading and does not necessarily represent the performance of the AI in practice. For AI in healthcare, it is important that AI reliably performs per the stated performance metrics to ensure that all clinics and patients that use the AI receive the improved health outcomes and clinical benefit. I'd like to thank you for joining this webinar. This presentation is available on our website at presagen.com. Thank you.